So, good day class. This will be the prelude discussion for exercise 3 entitled Saponification number determination. So, for the first part, saponification number is the number of milligrams of KOH or potassium hydroxide required to saponify or hydrolyze 1 gram of fat. So, basically, ito ay isang part of your analysis for your fats and oils samples. So the unit for saponification number is provided as milligram of KOH per gram fat, and this is a characteristic which varies according to the molecular weight of the component fatty acid. So minsan kasi yung ating fatty acid may differ depende dun sa ating oil component. That's why what we do is we use index in the means of mean molecular weight of the fat. So mean yung ginagamit natin. So hindi kasi kumbaga hindi same yung identity ng R group ng ating triglyceride sa ating fat, 'di ba? So, to compensate for that, ang ginagamit natin ay mean molecular weight. Okay? So, why mean? So, ito yung sinabi ko kanina, fats are mixtures of tags. Okay? And hence, no exact composition could be derived. And we make use of mean molecular weight since yung ating composition ay varying depending on the species and other factors. So the saponification number also provides us an indication of the chain length of fatty acid. Okay? So mamaya malalaman natin if yung value ba ng saponification number ay mataas. So ano yung indication niya doon sa chain length of our fatty acid doon sa ating oil or fat. Pag naman mababa yung saponification number, ano kayang ibig sabihin nun? Okay? So what we have here is the saponification of your triglyceride. So you have your triglyceride on the left side. And what happens here is a nucleophilic acyl substitution. Meaning your hydroxide will serve as the nucleophile. So siya ay yung rich with electrons. And it will attack the portion of your tags na electron deficient. So that is your carbon here. Okay? So once it was attacked by the hydroxide, so this will proceed with the hydrolysis of ester under alkaline condition. So what happens next is you will free your fatty acid. So ito yung magiging fatty acid salt since you have KOH here. So para may minus dito, then magkakaroon ng potassium plus dito sa ating fatty acid as well as the glycerol. Okay? So basically, pinaghihiwalay natin yung tags natin to its free fatty acid component and to its glycerol component. So for the procedure, first we have to standardize our sodium hydroxide solution by using potassium acid phthalate as primary standard. Okay? So medyo alam nyo naman na tong steps na to from your Chem 32.1, no? Yung ating standardization of NaOH. So, yung ating standardization should include data na by means of weighing by difference, yung pagkuha ng mass ng ating primary standard. Okay? Next is, after we have standardized our NaOH, we will standardize our sulfuric acid solution using our NaOH. Okay? Then, for the preparation of our samples, so we will melt our fat and oil sample. And what we did with our sample, yun din ang gagawin natin sa ating blank. Okay? So as mentioned here, we have to weigh our melted fat. So ita-transfer natin yung ating melted fat or oil dun sa ating e-flask using medicine dropper. So what we did here is weighing by difference. Okay? And then we will add alcoholic potassium hydroxide solution using burette. And yung pag-add natin is we have to make sure that the potassium hydroxide solution to be added is in excess. So, as you can see here, dapat in excess siya. Okay? So, yung paggamit natin ng ating alcoholic potassium hydroxide ay dapat yung alcoholic component ng solution should be coming from the use of aldehyde-free alcohol. Okay? So, pinakita naman sa video link in your study guides and your module kung paano ba ginawa yung aldehyde-free alcohol. Okay? And then yung aldehyde-free alcohol will then be used as solvent for the preparation of your alcoholic potassium hydroxide solution. So, bakit kaya kailangan alcoholic yung ating medium? It is used to prevent the hydrolysis of your potassium salt. Okay? As mentioned kanina, ito yun, di ba? Yung fatty acid natin will be on its salt form. So, meron kayong potassium salt dito. So, yung paggamit ng alcoholic medium is para ma-prevent yung hydrolysis of potassium salt. Okay? Then, we will attach the setup to reflux condenser. So, yung reflux condenser ay used to prevent the loss of alcohol. So, basically, parang nag-vaporize lang tayo ng ating sample. Then, upon vaporization, magkakaroon ng condensation dun sa condenser. Then, bababa ulit siya dun sa ating sample. So, parang umiikot lang yung ating alcohol dun sa ating system. And by reflux condenser, we prevent the loss of alcohol. Since, ang kailangan nga natin dito is yung alcoholic potassium hydroxide solution for saponification process. And this setup ay nakalagay sa steam bath until completely saponified yung ating sample. And it can be said that our sample is completely saponified if homogeneous na yung ating solution. Okay? Then afterwards, we will cool our solution and we will add phenolphthalein indicator. Then we will proceed with the titration of excess KOH. Kasi yung ating reacted KOH are used to saponify your fat and oil. So yung excess natin, since we have added excess KOH at the beginning, so yun yung itatitrate natin using our standard acid solution, yung ating sulfuric acid. Then lastly, we will calculate for the saponification number and the mean molecular weight using the data that we can gather through the whole process. Okay? Then after which, you have to do method blank. So yung method blank ay basically same ng ating sample pero walang sample. Okay? So instead na may melted fat ka dyan, alcoholic KOH lang yung ating meron doon sa method blank. So, ang essence nito is for us to determine the exact concentration of total alcoholic KOH in our solution dun sa ating solvent. Para yung makakompute lang natin ay solely attributed from the sample. Okay? So, for the calculation of saponification number, what we have here is, since we have the unit milligram potassium hydroxide per gram fat, so what we'll have here is this one. Basically, para makuha mo yung milligram KOH, ito ay milli-equivalent of KOH multiplied to the equivalent weight of KOH. Okay? So, yung milli-equivalent of KOH ay actually equal to the milli-equivalent total minus the milli-equivalent of KOH unreacted. So, yung total natin yung total, yung sa simula pa lang na dinagdag natin KOH na may excess. Then yung excess natin, yun yung hindi nag-react. Okay? So basically, ang MEQ or milliequivalence of KOH ay equal sa normality volume of the blank minus the normality and volume of the sample. Okay? Then yung equivalent weight naman ng KOH ay just equal to the milli-equivalent of multiplied to the equivalent weight. Okay? So, using our data gathered from titration, so saponification number is equal to the normality of sulfuric acid multiplied to the volume of the blank sample minus volume of the sample used for the titration multiplied to the equivalent weight of potassium hydroxide all over the weight of the fat sample in grams. Okay? And then, what we have here for the calculation of mean molecular weight, so yung mole fat natin ay equal sa mole ng KOH multiplied to 1 mole of fat over 3 moles of KOH. Okay? So, upon rearranging, what we'll have here is yung mean molecular weight ng fat ay equal sa mean molecular weight of KOH multiplied to 3. So, bakit 3? Kasi, di ba sa ating glycerol or sa ating triacyl glycerol, you have 3 fatty acid attached to your glycerol via ester linkages, di ba? So, kaya tayo nakamultiply sa 3 dito. Tapos, hindi naman natin sure if magkakaparehas ba yung fatty acid attached to your glycerol. That's why, mean molecular weight yung kinocompute natin. Hindi kasi siya distinctive. So, bakit kaya ito may 1,000 mg per gram na conversion factor? Kasi ang ating saponification number ay milligram ng KOH over gram of fat. So, para mag-cancel yon yung milligram per gram, so, nagkaroon tayo dito ng conversion factor na 1,000 mg per gram. So, at the end, you should be able to have the final unit of gram per mole. So, yung gram per mole na yun ay galing sa molecular weight ng KOH. Okay? So, what are the implications of your saponification number? So, your high saponification number means you have low mean molecular weight. So, bakit kaya ganun yun? Because you have more short-chain fatty acid. Okay? So, yung ating triacyl glycerol, if it has a fatty acid attached there na short yung chain niya, ibig sabihin, you'll have a more dense fat and oil. So, yung 1 gram of fat and oil mo, maraming available na short-chain fatty acid doon that can undergo saponification. That's why, ang implication niya ay you'll have a high saponification number. So, for example, we have coconut oil versus corn oil. So, yung coconut oil, the saponification number ranges from 246 to 260 milligram KOH per gram fat or gram oil. And for corn oil, the saponification number ranges from 187 to 193 milligram KOH per gram oil. Okay? So, based from their structure, basically, ang ating coconut oil consists of medium-chain fatty acid, while yung ating corn oil ay consists of long-chain fatty acid. So, if we compare the amount of fatty acid in 1 gram of oil, so yung 1 gram ng coconut oil, mas maraming fatty acid available kasi nga, medium chain lang siya. Unlike sa corn oil, na mas mahaba yung kanyang fatty acid in 1 gram. So, basically, mas konti yung fatty acid na present doon. Kaya nangyayari, since mas konti yung fatty acid doon sa corn oil, mas konti ngayon yung fatty acid that will be available for saponification. Kaya mas mababa yung saponification number ng corn oil compared to coconut oil. Okay? So, as mentioned here, esters of fatty acids of low molecular weight will require more amount of base for saponification than the same weight of samples with higher molecular weight. So, what happens if your okay, ito yung ating second implication. So, the saponification number increases with increasing number of molecules of short-chain fatty acid. So, as mentioned kanina, mas madami kasi yung available carboxylic group available for saponification. So, yun. And lastly, since ang ating saponification number is index used for identification, so hindi siya measure for evaluation of quality. Kaya yung ating saponification number is not affected by deterioration. Okay? So, rancid man yung ating oil or hindi, so hindi siya affected. Yung saponification number hindi affected by rancidity of the oil. Kasi yung ating oil present there ay tags pa rin naman. Yung tags natin ay maybe may mga fatty acid pa rin na naka-link doon via ester linkages. And ma-determine pa rin natin yung saponification number niya since yung number or amount of carboxylic group nga yung ating determine when it comes to saponification number. Unlike for the quality per se, this will be tackled for the future module. Pero what you can have here is that pwede kasing magkaroon ng deterioration kapag yung free fatty acid na yung naapektuhan. Okay? For example, meron kayong unsaturation or pwedeng yung fatty acid ninyo ay na-hydrolyze from your uh, tags, meaning humiwalay siya dun sa ating glycerol na mother chain. So, yun. So, yun yung mga types of test for evaluation ng quality. Pero for saponification number, hindi siya affected by deterioration. Okay? So, for your tables ng ating pre-lab report, so this should be the inclusion of your tables. Okay? So, number 1, dapat meron kayong mass of oil by means of weighing by difference. Okay? So, we have 2 trials for this. And then, for the determination of volume of alcoholic KOH dispensed from the base burette, dapat meron kayo nun. Okay? Next is the determination of volume of 0.5 normal sulfuric acid used to neutralize oil sample after reflux. And the determination of volume of 0.5 normal sulfuric acid used to neutralize the alcoholic KOH after reflux. So basically, this is your sample and this is for your blank. Then for number 5, determination of saponification number and mean molecular weight of the oil sample. So this is for your derived data. Okay? And then for the last table, likewise for your exercises 2 and 3, exercises 2 pala, sorry, your specific gravity, you should included here the possible identities of your oil na table, na data blank. Okay? So dito, dapat meron din kayong table for standardization part. Okay? Alright. So I think that will be the end of the pre-lab discussion for Module 3. So basically, dapat intindihan nyo lang na yung ating saponification number ay what we did is we added an excess amount of potassium hydroxide. Tapos yung potassium hydroxide natin will react with our fats and oils. Then yung excess nating KOH na unreacted will be titrated using our standard acid. And by then, we can calculate for our saponification number. And you should be able, or you should take note of the following precautions as you can see from your screens na kung ano yung dapat na weighing technique na na-employ and kung ano yung mga dapat na ginamit na alcohol solvent and bakit siya kailangang alcoholic yung nature and bakit tayo gumamit ng reflux condenser and so on. Okay? So, this will be the end of the pre-lab discussion and thank you for listening.